So now we are going to perform the 4-point bend test, wherein we are going to use the DIC technique to capture the images and then later on process them to get the strain field. So firstly, let's see the setup of the experiment. This is the 4-point bend fixture. This is the top fixture and this is the bottom fixture. We have placed a scale in order to measure the length, which I'll explain later on. This is our specimen which we had speckled earlier. We have set it such that the clearance on each side is 1 centimeter each, and the distance between these 2 points is 40 mm, and this 2 is again 40, so 40 40 40, and the clearance of 1 centimeter each. Now let's see the DIC setup. So for that we'll require lights and the camera. Here, as you can see, these are the two lights, monochromatic lights. I'll switch them on. They are placed such that the light falls maximum on the specimen, and this doesn't come, the lights are set such that they don't come in between the camera and the specimen, and the specimen is visible clearly. So let's switch on the lights. I have already set them up. As you can see, the lights are already set. Okay, now you can see here is our camera. This is our micro lens and the bachelor camera, 30 micrometer camera. This has been connected, this port gets connected to our laptop, which I will show later. Now remember, the camera needs to be set such that its focal line is actually perpendicular to the flat surface of the specimen, such that it remains in this manner. Like this is the specimen surface and this line of sight remains perpendicular to it. So let's set up the camera settings for the Bessler camera. For this we'll need Pylon Viewer software. Here I have used Suite 5.1 version, 5.0 version for the Pylon Viewer. You can download it freely from browser, your web browser. So let's see. Starting the camera. Now the port from the camera has been connected to my laptop. This is how the screen looks like for the bachelor camera. Now as you can see, there is this option which shows the name of the camera. If the port is not connected properly, then this option will not be seen. So once it's shown, double click on it. This recording button, as you can see, it got activated. That means the camera has been successfully connected. In order to first adjust the field of view, we are not going to start our recording, but we are going to select this option that says continuous shot, which will give us the live images without capturing the various frames. So here, now you can see this is the image that is visible. In order to adjust its contrast, we'll go to this Bessler option. Under that, acquisition control. Here you can see exposure time. Upon increasing the exposure time, the brightness will increase. I'll show you. Let's say I am setting it to 7000. See, the image became more bright. Now if I lower it to, let's say, 2000, it became very dark. So you have to optimize it such that the speckle pattern is clearly visible. Now remember, very high the exposure time, there will be buffer in capturing the images, which should be avoided. So try to keep exposure time as low as possible. The default here is kept at 3000. Try to keep your exposure time near to 3000 to 5000 so that there is no buffer in capturing the images. Now if you wish to if you wish to adjust the height and width of how much area is captured, for that you can go to image format control. Here you can see the width, height, offset X and Y are set. Width and height are here disabled because this is a continuous shot. If you want to adjust them, stop this continuous shot. If I stop it, you can see the height and width are activated. You can reduce them and increase them, which will reduce or increase this thing. Let me show you. So let's say I'm trying to decrease the height. I decreased it. You can see there is no effect here in the field of view because this is not a continuous shot. Now let's keep it to continuous shot by selecting this continuous shot option. So if I click it, see, the height got reduced. Now suppose I need to change or offset this image. So what I'll do is, you can see there is this offset X and offset Y. I need to change the Y axis. So what I'll do is, see, if I change it, the offset changes. Now let's optimize it. I need the scale in view as well because I'll be needing it to measure to input the length in the DIC 2D software while I'll be processing it. So let me increase the height. I need the height more because I need the scale in my view. And now, yes, you can see the scale is clearly in view as I can clearly see it, and then later on I can input the value. Correct. Now as you can see, the adjustments in the camera are done. Now after setting up the various parameters for the camera, let's move on to what we need to set in the UTM machine. So first we have to switch on the machine and then start the software. Here I have already started the software, so let's move on to what we have to do. So upon starting, you will see such kind of screen. In that, first you need to set the method. So we are going to perform 4-point bend test. So here first we'll go to tab options. In that, in the method part, we'll go and select the generic flexure 4-point, F4PT, that is written. Remember to disable the demonstration mode here. Click on OK. And it's done. So this is the kind of screen that you will see. Now moving on towards setting various parameters. So we'll go to the method editor tab. Now in the first screen, that is the first tab, method overview, you have to do nothing, just save. Remember to click save button after inputting data in each tab. Next we'll move to source selection. Under that, keep all the check marks, all the boxes ticked. Save. Next moving on to parameters. So under that, here we are using flat specimen. As you can see, there are many options depending upon the type of specimen that you are using. Here I am using a flat beam specimen, so it's flat. In this 3 options, test direction, remember to tick on the compression, otherwise it will perform tensile experiments, which is not required. So remember to click on the compression. As you scroll down, you will come to curve storage part. Remember to tick on actual points. If you do user specified points, the machine will stop after collecting 1000, let's say 1000 points, and your experiment will be still on, but you won't be able to capture that data. So remember to check that the actual points tick box is checked. Then save and proceed towards entries tab. In the entries, you have to enter the width, thickness, support span and upper span. Now remember, in the 4-point bend test, we are not placing the specimen in this manner. We are placing the specimen in this manner, and the load is going to, the rollers are going to touch here. So for this thing, this is going to be my width, and this portion is going to be my thickness. That means for my specimen, the thickness here is 15 mm and the width is the thickness of the sheet, that is 5 mm. So accordingly, let's see here. As you can see here, I have entered the width as 4.816 mm. I measured it using vernier calipers. Thickness is 15.093 mm. Now support span, that is the span between the lower two rollers, is 120 mm and the distance between the upper two spans is 40 mm. After entering this data, save, and then let's move on to data importing. Data importing, you don't have to do anything. Move to control segment. Now here we are doing loading and unloading of the specimen at a rate of 0.54 mm per minute. So first we are going to load the specimen up to a predefined deflection. For my case it's 5 mm, and then we are unloading the specimen till the load cell feels the load of 0 Newton. So for that, first I have set the first control method is going to be positive rate, as in the upper fixture is going to move downwards, so plus 54 mm per minute. The end condition is when the value reaches the end value. Now what is going to be the end value? The end value will be a position value which has been set here. And what is going to be that value? 5 mm. Here is mm. The second part is unloading part. So again, the rate of position is going to be minus 0.54 mm per minute, because this time we want the fixture to move upwards rather than downwards. Again, when up to what? When the value reaches the end value. End value of what? That is force. And how much force I need at the end of my experiment? That is 0 Newton. Remember to check the plus and minus sign and these end conditions. After setting it, click on save. Indicated. Now similarly, I'll show you how to acquire data in the camera portion. So once you have set all the parameters, you can see the red dot that is there. Click on that red dot. So this screen will appear. Under that, here the 3 dots, you can browse and save in the folder wherein you wish to save your images. I have already selected the folder. Once the folder has been selected, you can set the image capture rate by going to the sampling part. Now herein it's set to 1000 milliseconds, 1000 per millisecond. That means one frame will be captured in 1 second. You can adjust this accordingly. If you wish to capture 2 frames in 1 second, you can set this value to 500. Now once it's done, go to recording part and you can click start recording. Now for this experiment, what we are going to do is, we have to actually click the start recording button and the start button of the UTM at the same time. Now why? Because I want the data to be captured from both the camera as well as the UTM at the same moment, so that I can extrapolate one data from the frame. I can extrapolate the data or the frame from my all sets of frame to a single point from the data in the UTM machine. So we'll be starting the experiment by clicking on play button at the same time.